You know, when you think of Albert Einstein, I bet a very specific image pops into your head, right? The wild hair, the wise old eyes, the absolute icon of genius. But what if I told you the real story? The story of how his greatest ideas were born started somewhere completely unexpected. We're going to peel back that legend and find a young man in a quiet office whose day job, of all things, became the key to unlocking the entire universe.
So yeah, on the left, there's the legend we all know and love. But over on the right, that is the guy we're talking about today. This is Albert Einstein in 1905. He's only 26 years old. He's not some celebrated professor at a fancy university. Nope, he's a technical expert third class at the Swiss Patent Office. And that contrast right there is the entire heart of this story. How on earth does this guy go from examining other people's inventions to completely rewriting the fundamental laws of space and time?
Okay, so let's set the scene. It all starts here, at the Swiss Federal Office for Intellectual Property. Back in 1902, after really struggling to find any kind of academic job, Einstein lands this gig as a patent clerk. To anyone else, it would have looked like a huge detour, right? A step away from his real passion for physics. But it turned out to be the most important detour of his entire life.
And you'd think he'd hate it, but he didn't see the job as a burden at all. In his own words, he called the patent office that worldly cloister where I hatched my most beautiful ideas. A cloister. I love that. For him, it wasn't a distraction from his real work. It was this perfect incubator, a quiet, focused place, totally removed from the publisher-parish pressures of the academic world.
What's so fascinating is the incredible structure this job gave him. He divided his day up perfectly. 8 hours for his job, which he playfully called his cobbler's trade, 8 hours for sleep, and then a solid 8 hours for what he called a lotria, basically miscellaneous stuff. And for Einstein, miscellaneous stuff meant his own private, passionate, deep dive into the biggest questions in physics. The job was just demanding enough to keep him sharp, but not so demanding that it drained him. It left his mind totally free to just wander the cosmos.
So what was he actually doing all day? Well, his official task was to evaluate patents, specifically patents for electromagnetic and electromechanical devices. Now, this wasn't just stamping random papers. This put him right at the cutting edge of the biggest technological puzzles of the day. And one puzzle, in particular, kept showing up on his desk.
And this is where things get really interesting, because at the turn of the 20th century, the world of physics was facing a massive crisis. I mean, its two main pillars, the very foundations of everything they thought they knew, were starting to crack.
Just imagine that for a second. What do you do when the two most successful theories you have for explaining how the universe works just flat out disagree with each other? This wasn't some tiny little error. This was a full-blown universe in conflict kind of problem. And it had the greatest scientific minds of the era totally and completely stuck.
And here's the conflict, laid out side by side. On one hand, you've got Newton's laws of motion. They'd worked perfectly for centuries. And they say that all motion is relative. Simple enough? But then, on the other hand, you have James Clerk Maxwell's incredible equations, which perfectly described electricity and magnetism. And buried in those equations was something really weird. They said that the speed of light is an absolute constant. So how can both of those be true? Look, if you're on a speeding train and you throw a baseball forward, its speed is relative to the train. But if you turn on a flashlight, Maxwell's equations say that beam of light shoots out at the exact same speed whether the train is moving or not. It just didn't make any sense.
Boom. This is where the patent office comes roaring back into the story. A huge technological push at the time was trying to perfectly synchronize clocks over long distances. Think about coordinating train schedules across the country. Einstein's desk was literally flooded with patents for all sorts of gadgets trying to do exactly that, using electrical signals that travel at the speed of light. Now, the actual records are gone, but we're pretty sure this work forced him to think, day in and day out, about a very practical problem. What does it actually mean for two events happening far apart to be in sync? He was wrestling with the very definition of simultaneity.
All of this quiet thinking, all this mulling over time and light and motion, it all came to a head in 1905. It was a year so unbelievably productive that scientists now call it his annus mirabilis, his miracle year. Out of the quiet of that Bern patent office, an absolute explosion of ideas was about to be unleashed on the world.
I mean, just look at this timeline. It's absolutely mind-boggling. In 1 year, this 26-year-old patent clerk publishes a groundbreaking paper on the nature of light, provides the first real experimental proof that atoms actually exist, gets his PhD, and then, in June, sends off the paper that introduces the world to his special theory of relativity. and then he cops it off later in the year? The sheer breadth of genius on display here is just staggering.
The real genius of his approach in that June paper was this. He didn't try to just patch up Newton's old laws or find some weird loophole in Maxwell's equations. No. He took a huge step back and asked a bigger question. What if both theories are right? What if the problem isn't the theories, but our fundamental assumptions? What if we just need to rewrite the rules from the ground up, based on two simple, powerful ideas?
So, here's idea number 1, the principle of relativity. Basically, he took an old idea from Galileo and just supercharged it. He said the laws of physics, all of them, including the new ones for electricity and magnetism, have to be the same for everybody who's moving at a constant speed. There's no special at-rest spot in the universe that gets a better view. Everyone's perspective is equally valid.
And then there's the second idea, and this one was truly radical. He just decided to accept that weird result from Maxwell's equations as a fundamental law of nature. The speed of light in a vacuum is constant. It's the ultimate cosmic speed limit. And no matter how fast you're moving, or how fast the thing shining the light is moving, you will always measure its speed to be exactly the same.
Okay, so what happens when you decide to believe both of those things are true at the same time? Well, you're forced to accept some seriously bizarre, seriously mind-bending consequences. It meant nothing less than a complete and total rewrite of our concepts of space and time themselves.
To solve that paradox between Newton and Maxwell, something had to give. And it turned out what had to give was our deepest, most common sense understanding of reality. Einstein realized that space and time are not this fixed, absolute stage that the universe plays out on. No, they're flexible, they're malleable, they are completely and utterly relative to your motion.
And the results are just wild. Get this, the faster you move through space, the slower you actually move through time. That's called time dilation. Things that are moving actually get shorter in their direction of travel. And remember that whole problem of simultaneity from the patent office? Einstein solved it. It turns out, two things that seem to happen at the exact same time for you might happen at totally different times for someone else moving differently. Time itself is personal.
And then, almost as a little side note, a few months later, he worked out the final consequence of his theory. And it was this, the most famous equation in all of science. It's the elegant, powerful statement that mass and energy aren't separate things at all. They're fundamentally interchangeable, just two different sides of the very same cosmic coin.
And just like that, the great conflict in physics was over. Newton and Maxwell were finally reconciled. A new, unified picture of reality emerged, and our universe would never, ever look the same again. And it all started in the mind of a young man thinking about the universe in his spare time, sparked by the very practical puzzles that crossed his desk every single day.
Einstein himself seemed to know exactly where these incredible breakthroughs came from. It wasn't about rigid discipline or academic pressure. He said it was all about the divine curiosity and the play instinct. It was that freedom to just be curious, to play with ideas like they were toys, that allowed him to see a universe that no one else had ever imagined.
And that kind of leaves us with one last thought, doesn't it? Einstein's story is the ultimate proof that revolutionary ideas don't always come from the obvious places, from the big labs or famous universities. So it makes you wonder, where are the worldly cloisters of today? In what quiet, unassuming corners of the world might the next Einstein be hatching their own beautiful, world-changing ideas right now?